Assalamualaikum and hi everyone. Today we are going to do generate skill 2, which is environmental control in coal-fired steam power plant. Before that, let me introduce myself. My name is Muhammad Muhaimin bin Muhammad Ramzi. My message number is 01DE 24F1051. My partner.
My name is Aidi Zikri bin Ahmad. My method number is 01DE24F1065. So let's go for
Introduction. So let's go to our introduction. Introduction is coal-fired steam power plant are widely used to generate electricity because coal is abundant and affordable. However, burning coal produces harmful pollutants such as sulfur dioxide (SO2), nitrogen oxide (NO2), carbon dioxide (CO2), particulate matter and heavy metal. These pollutants cause air pollution and acid rain and climate change, which negatively impact the environmental and human health. To reduce this effect, modern power plants use various environmental control systems. Technologies such as electrostatic precipitator (ESP) and bed filter remove dust and ash. Flue gas desulfurization (FGD) reduce sulfur emissions. Selective catalytic reduction (SCR) lowers nitrogen oxide and carbon capture and storage (CCS), helps control greenhouse gas. These control systems are essential for meeting environmental regulation and promoting cleaner, more sustainable power generation by applying advanced technologies. Coal-fired power plant can operate efficiently while minimizing their environmental impact. Let's go to air pollution due to emission from coal combustion. Coal combustion release several harmful gas and particles into the atmosphere, leading to serious air pollution problem. When coal is burned to produce electricity, it emits pollution such as sulfur dioxide. Sulfur dioxide causes acid rain and respiratory problems. Next, nitrogen oxide contribute to smoke formation and acid rains. Next, carbon dioxide, a major greenhouse gas responsible for global warming. Particulate matter, dust and ash can cause lung disease and reduce air quality. Also, mercury and heavy metal, toxic pollutant that can contaminate water and soil. These emissions can damage ecosystem, harm human health and contribute to global climate change. Therefore, effective emission control systems are necessary in coal-fired power plant to reduce air pollution and protect the environmental. So, control strategies and solution. ESP remove dust and fine particles from flue gas. FGD reduce SO2 emission. Low NOx burners decrease formation of nitrogen oxide. CCS traps CO2 before it enter the atmosphere. Switch to cleaner fuels or renewable energy alternative.
As we go for environmental control strategy for components responsibility for pollutions. First is emission stack chimney. After treatment, the clean flue gas are released into the atmosphere through the emission stack. The tall chimney help disperse the gas over a wider area, reducing the pollution concentration near ground level. Modern stacks are also equipped with continuous monitoring system to ensure emission levels meet environmental standards. Second is ash disposal system. Coal combustion produce bottom ash fly ash, which must be properly managed to prevent land and water pollution. Ash handling system collects, transports, and dispose of the ash in the designated area or reuse it in construction materials such as cement and concrete. Promotion suitable waste management. Third is a cooling system. Consider power plant also generate terminal pollution through the discharge of hot water from cooling system to minimize this impact. Cooling tower or closed loop cooling system are used to lower the temperature of water before it is released, helping protect aquatic life and surrounding ecosystem. Next, we go to electrostatic precipitator, ESP, and fabric filter, bag filter. For the feature, we have a working principle, efficiency, apparent temperature, maintenance, space requirement, cost, and best for. We go for the working principle. For the ESP is a used electric field to charge a collect dust particle on plate. For fabric filter is a use for brick bags to physically trap dust particle as gas pass through. For the efficiency, ESP is a high efficiency up to 99% for large particle, less effective for very fine dust. For the fabric filter is a very high efficiency over 99% even for fine particles. Let's go, we will go for operating temperature. For operating temperature, ESP can operate a higher temperature up to 550 Celsius. And for the fabric filter, limited to lower temperature, usually below 150 Celsius. For maintenance, ESP is a required product cleaning of collisions, plates, less frequent maintenance. For the fabric filter, is require regular cleaning or replacement of a bag. Next, space requirement. ESP is a large in size and require more installation space. For fabric filter, is more compact and require less space. For cost, ESP is higher initial cost but lower maintenance cost. For fabric filter, is lower initial cost but higher maintenance and replacement cost. For best for is a large power plant with higher flue gas volume. For fabric filter is smaller and medium sized plant requiring higher dust removal efficiency. Next is SDG 7, affordable and clean energy. Sustainable Development Goal 7. SDG focus on using access to affordable, reliable, sustainable, and modern energy for all. Energy is essential for economic growth, education, healthy care, and improving quality of life. However, millions of people around the world still lack access to electricity and rely on harmful fuel for cooking and heating. This goal aims to increase the use for renewable energy, such as solar, wind, and hydropower, while improving energy efficiency to reduce environmental impact by promoting clean and affordable energy. SDG 7 support global effort to combat climate change, protect the environment, and ensure the sustainable future for the next generation. Thank you so much.